Is it audible now? Is it clear now? Or it's
Yes,
still
ma'am.
breaking? Okay, just wait a minute. My voice is breaking. No, just wait a minute. Let me check the connection. Is my voice audible now? Is it fine?
Yeah.
Okay. So in the last class, we had started with the resolution of vectors, resolution of components we had seen. So angle that the axis makes with, that we consider it as cos theta, and the perpendicular to it, we consider it as sin theta. Now, resolution of vectors we had seen. Out of these, no certain rectangular components are left to be discussed. See, in 2 dimensions, we have discussed, if you have cos theta, when you have to consider cos theta, when do you have to consider sin theta, right? Now, under resolution of vectors in 3 dimensions, means you have x-axis also, y-axis also, and z-axis also. So in that case, how will you consider? Suppose this is your, all the 3 axes are present, rectangular components in 3D. So this is your z-axis. Let's say this is z-axis, this is x-axis, this is y-axis. So this is alpha, this angle that x and z make, and z and y make, this is beta. And the angle that z and x axis make, we consider it as gamma. So all the 3 axes we have written it. Now see, how will you now consider the component? So suppose this is the vector A on the z axis. So A alpha means this angle component, this will become A cos alpha. Similarly, when you have to find out the component along y-axis, whenever you have, this is suppose along x-axis, so this is A cos alpha. Let me write it as x-axis only. When you have to write the component along y-axis, so which angle is along y-axis? That is beta. So you will write it as A cos beta. Lastly, when we have to write A along z-axis, that time we'll consider A cos gamma. Now, when you have to find out the magnitude of the vector A, so again, these are the individual components of the unit vectors. How do we calculate the magnitude? This will remain same. Under root ax square plus ay square plus az square. This part will remain the same. Now, what is the value of cos alpha from here? Yes, Sarah, how will you write the value of cos alpha from this equation? This is your entire ax is equal to a cos alpha. How will you write the value of cos alpha from here? Yes, Sarah. Yes, how will you suppose ax is equal to a cos alpha? So cos alpha should be
ax by a.
ax by a. Very good, Martin. It would be ax by a. Simple division. This is how you will get all the values of angles. Cos alpha will become ax by a, means component of a along x-axis divided by the vector a. Similarly, cos beta will be ay by a, cos gamma will be az by a. This way, you will get all the angles. Now see, if you square them and add them, suppose if I square all these angles and I add them, this is cos square alpha plus cos square beta plus cos square gamma. What is the value of cos alpha? Martin has just now answered ax divided by a. So this whole square plus what was cos beta? Ay by vector a. So whole square of this plus what was cos gamma? Az by a. So cos square gamma will become square of this vector. Right? This is what we'll get. Now see, if you can notice here, a square is common. So let me make the common denominator as a square. What will be left over here? Ax square plus from here ay square plus az square. Right? Now class, remember which component is a? Right now we have just written the magnitude of the vector a, under root a square plus ay square plus az square. So your a is actually under root ax square plus ay square plus az square. So if I square a, it means I will get ax square plus ay square plus az square, right? So can I, in term of this, put this equation? See, so what will I get? Cos square alpha plus cos square beta plus cos square gamma. This will be equal to, this entire term can be written as a square, and there is a square already in the denominator. So it means, what is the final answer I'm getting? Cos square alpha plus cos square beta, they'll get cancelled, plus cos square gamma is equal to 1. Sometimes in your exam, this proof can be asked to you. Usually this is not asked. From resolution of vectors, we get these types of questions only, where you have to resolve the vectors, find a component along x-axis and y-axis. But just in case, sometimes these questions have come that prove that cos square alpha plus cos square beta plus cos square gamma is equal to 1. So you have to show this derivation. So just make a note point and write it down. Then we'll practice some questions from here. Resolution of vectors from here. Yes, what is the magnitude coming? The vector that is given to you is 2i cap minus 3j cap plus 4k cap. At least magnitude first part all of you should be able to answer. Martin, Yasir, Sarah. Quickly, last 1 minute. At least magnitude all of you should answer correctly. Yes, Martin, what is the value coming?
Yeah.
What is the value of magnitude coming?
Oh, ax square plus ay square plus az square.
Ma'am, 4.
Root 4. Sarah says root 4.
No, only 4.
Martin, your answer. I'm still waiting. Calculate and tell me. Yasir, your
Okay,
answer.
ma'am.
Root 4 means 2, no, Sarah? Means your answer is coming 2.
No, I got root 16 and then I got 4.
Acha, you're getting root 16. Your answer is 4.
Yeah.
Okay. Sarah's answer is 4. Yasir, your answer. Magnitude, by now, all of you must know how to calculate. Without magnitude calculation, how will you proceed further? We have to start with projectile motion now this week. Everywhere you will be getting these types in Cartesian form. See. Yes, Yasir, Martin, any answers?
Ma'am, I'm almost done.
Okay, I'll start the discussion. Please match your answers. Yes, Yasir, very good. Answer is right. See, we have to take the square of each coefficient. I cap, what is the coefficient of I cap? This is 2. So this becomes 2 square plus. What is the coefficient of j? It's minus 3. So minus 3 square plus. What is the coefficient of k cap? 4. 4 square.
Ma'am, it's minus 2i minus 3.
2i cap minus 3j cap plus 4k cap. Yes, yes, Martin. So this
Ma'am, I
becomes,
took 3.
how much you're getting, Sarah?
I took 3. I took 2 as 3. So
That's why your answer was coming wrong. Just check your calculations again. Meanwhile, I'm writing. Try to match your answer. This should come out to be root 29. Yasir's answer is correct. Root 29 is the right answer. See, minus 3 into minus 3 will again become 9. This is 16. 25 plus 4. This becomes 29. Now, one addition, see this question by now, all of you should be able to solve these types of questions. Practice these questions where magnitude, vectors, unit vectors are asked. That's why we have done this in detail. Direction cosines, if just in case this is asked, this is something new which you have not done before. That's what we have studied. Whenever direction cosines are asked, direction cosines mean these. Your cos alpha, cos beta, cos gamma. These are your direction cosines, which we have just now studied. So this you can now conclude. What did we study regarding cos alpha? Cos alpha was ax, means coefficient of I cap, divided by their magnitude. So ax, what is the coefficient of I cap? It's 2. And what is the magnitude? Root 29. So cos alpha will be 2 by root 29. Coming to cos beta, that is ay by vector a, not vector a, magnitude of a. So what is ay? This is minus 3, coefficient of j cap. And what is the magnitude? Root 29. cos gamma. Cos gamma is AZ by magnitude of this vector. So what is AZ? The coefficient of Z axis, that is K cap, is 4 and magnitude is 29. So just in case direction cosines are asked, this is one additional step which you have to follow. But until your magnitude, all of you must be able to answer. Fine, note down this, then we'll start with dot product and cross product. That is the last topic which is left from your vectors. Apart from this, so by this week, we should complete that. Horizontal projection is also there, angular projection. These two parts, your projectile motion is divided. But vectors was a very basic thing which you have to understand. After this, we'll start with last topic is dot product and cross product, that are also very important. Yes, see, now coming to dot product and cross product. Now see, when we see dot product and cross product, before that you have to understand, when we multiply vectors with vectors, what we get. See, if you are having a vector getting multiplied with just a number, let's say velocity, some velocity is there that is getting multiplied by 2. So two things can occur. You can either get the value as positive or you can get the value as negative. Both are possible. Fine. So in this case, if you just multiply a vector with a number like velocity 4 meter per second multiplied to 2, what do we get? 4 into 2, that is 8, means magnitude becomes n time. So here the magnitude becomes n times, where your n is just a number. Fine, n is just a number. That is what you have to consider. Fine, this is the basic of it. Now, when you multiply vector with a scalar quantity, three things we are discussing: vectors, scalar, and a number. Number can be any number from 0 to infinity. Any number can be chosen. Vector getting multiplied with a number, magnitude just becomes n times. If 4 is the vector, let's say 4 meter per second is the magnitude of velocity, and we are multiplying it with just a number, let's say 2. So magnitude will become 2 times whatever is the velocity, that is 8. So magnitude becomes n times. That is when you multiply a vector with just a number. But if we multiply a vector with scalar, right, if you multiply vectors with scalar quantity, in those cases, see, let's say your vector will become n times. Let's say n is just a scalar number. So here also magnitude will become n times, means your n is a scalar. N is a scalar number. So it will become. But now these are the two cases which we have been discussing. See, this is nothing new. Whenever we have been multiplying till now, we have just multiplied it the way simple multiplication works. But now coming to, if you multiply a vector quantity with a vector quantity. For example, we have one formula of power as force into velocity. So force is also a vector quantity. Velocity is also a vector quantity. So now how will you solve it? Will you apply simple multiplication if you have power is equal to force into velocity? No. You have two cases how to solve these types of questions. One, we call it as dot product. Second, we call it as cross product. Depending upon their formula, we will use. For example, this I am telling you the way this example, power is equal to F dot V. We do not simply multiply force with velocity because we are multiplying a vector quantity with another vector quantity. So power will be F dot V, means dot product we are using. Now how to solve dot product, that we will see in the later section. How to solve cross product, that also we will see. But power is, if for example power is force dot velocity, you will not simply multiply, you will apply the proper procedure for dot product. So this is dot product and this is cross product. By dot and cross, you will be able to identify. This part is just left to cover. This entire portion we have covered. This last portion, this is yet to be discussed. See, unit will remain the same. In all the cases, units will remain the same. Units will remain the same when the scalars are getting multiplied to vectors, or when your just number is also getting multiplied. Now see, consider this example. Force is equal to 2 I cap Newton. And I've just taken a random number as 3. So NF, if you are multiplying this vector quantity with this number, so 3 multiplied to this vector, that is 2 I cap. So that becomes 6 I cap and your unit will remain the same, 6 Newton, 6 I cap Newton. Here I have acceleration. Let's say now I'm taking a scalar quantity. Acceleration is my vector quantity. Mass is my scalar quantity. So the formula of force is F is equal to ma. Formula of force is F is equal to ma. This we have in our Newton's law of motion also. Now see, it means 2 I cap multiplied to 2. That gives you 4 I cap. Fine. So this is how we consider. Now let us start with proper dot product first, then we'll discuss cross product. But to note down this, make this table first. Then I'll start with dot product first. Yes, class. Now see, when we use dot product, no, when you are multiplying a vector quantity with vector and the result is a scalar, like power. Power is a scalar quantity, but force and velocity both are your vectors. So vectors getting multiplied to a vector, where we use dot product in the cases where the quantity is a scalar. Now suppose if I give you an example, torque. Torque is R cross F. Position vector, force is a vector, and torque is also a vector. So in such cases, when you multiply vectors with vectors and the result is also vector, then we use cross product. And when do you use dot product? When you are multiplying scalars to vectors to vectors, but result is scalar. So suppose you are having two vectors, A vector is there, B vector is there, and the angle that is being subtended by both the vectors is theta. How to solve it? Firstly, you will notice somewhere we do not put the multiplication sign, we put a dot. So that is actually dot product. We multiply here, but with a different method. How do you multiply? If I give you this question, A dot B, how will you solve it? Take the magnitude of the vector A. When I say magnitude means you're not considering any sign. For example, -4 is given. You will choose it as 4. +4 is given, still you will write it as 4. Magnitude means without any sign, you're just taking sole number. So magnitude of A multiplied to magnitude of B multiplied to the cos theta means the angle between the two vectors. So it means how can we write? A vector dot B vector is equal to AB cos theta. What is AB? A is the magnitude of A, B is the magnitude of B. For example, this example I have written V2 is -3 meter per second, V1 is 5 meter per second, and angle between them is 60 degrees. Now I want to find out V1 vector dot V2 vector. So how will I put? I will first consider the magnitude of this V1, then I'll take the magnitude of this V2 and I'll multiply it with the angle that is being made. So V1 dot V2, see magnitude of V1. What is the magnitude of V1 from here? This is V1.
5 meter per second.
5. Yes, just 5. Meter per second is the unit. V1 is the physical quantity. So just 5. Very good, Yasir and Sarah. So this is 5. V2, yes. What is the magnitude of V2 class?
-3.
3.
No, not -3. It's, yes, Yasir. It's just 3. See, when we are saying magnitude, you do not have to consider any signs. If I am saying this is -3 meter per second, magnitude will be 3 only. So this is 5 multiplied to 3 multiplied to cos 60 degrees. So that becomes 5 into 3 into half. That is 15 by 2, which is 7.5 meter per second. This is your answer. Certain properties we'll see. Before that, note this down. Then I'll make you write certain properties on application of dot product. Any doubts you can ask. Yes, coming class to the properties of dot product. See, firstly, as we have discussed already, when you are multiplying a vector with a vector and you are using dot product, your result has to be scalar. The example I gave you of power is force dot velocity. Or work done also you can take. Work done is what? That is F dot S. Force dot displacement. All these things will come in the upcoming lessons. You have work, energy, and power. You have laws of motions. Everywhere you will be having these. So that's why please prepare dot product and cross product. These are very basics and these will be used throughout. Your torque will come in rotation, work done will be there, power will be there, all these quantities will be there. Now this is commutative. Commutative property means, like, see, the way multiplication is commutative. If you multiply 2 into 3, you can write it as 3 into 2 also. Both the answers will be same. So here in dot product also, if you are writing A dot B, it's not necessary that you have to always write A dot B only. You can write it as B dot A also. Answer will be the same. That is not valid in cross product. That's why this is an important property. The way in multiplication we can do, no, 3 into 2 is 2 into 3. You can either write in either ways. That is valid in dot product also. Now the regarding the perpendicular vectors. This I have, I think, I do not remember if I have told you this when we were discussing dot product or not. Perpendicular vectors. See, why, if you take perpendicular vectors, your cos theta will become 90 degree. Directly answer will be 0. So let's talk about the universal vectors which we have. What are the universal vectors? I cap, j cap, k cap, right? So I cap dot j cap will be 0. The perpendicular vectors, right? I cap is the vector, I cap is on the x-axis, j cap is on the y-axis, j cap is the unit vector for y-axis. So these are perpendicular to each other. So if you take the dot product of I and j, it will be 0. Similarly, let's talk about this third one, j and k. J and k, let's take this. So j cap dot k cap, this will be 0. I cap dot j cap, like you can take k cap dot I cap, this will also be 0. So perpendicular vectors will be 0. But let's talk about parallel vectors. What is cos 0 degree? When we are talking about parallel vectors, your theta will become 0. When we talked about perpendicular vectors, theta was 90. So cos 90 became 0. When we are talking about parallel vectors, so in parallel vectors, we have to consider, it means this is vector A, this is vector B. So angle, I have repeated this multiple times, angle becomes 0 degree if two vectors are parallel. If they are anti-parallel, then it is 180 degree. But right now I'm talking about parallel vectors, means theta is 0 degrees. So if you take A dot B and they are parallel, so AB cos 0 degree means you will get AB only. So here that is, if you are taking, it means you are taking just their magnitudes, right? So if I take I dot I, what is the magnitude of this? Unit vector. What is the magnitude of a unit vector? Very good, Yasir. It's 1. Magnitude of a unit vector is 1. So magnitude of I, this is also 1, this is also 1. Similarly, if you take j cap dot j cap, or if you take k cap dot k cap, all these will be 1 because I cap and I cap, they are parallel to each other, means on the same axis. K cap dot k cap on the same axis. Similarly, j cap dot j cap on the same axis. So A dot B, B dot A, all these become 1. Last property, that is A dot A, means if you are taking multiplying the same quantities. So see, when you take A cos 0 degree, you can take A square if it's not a universal unit vector. For universal unit vectors, I have told you I dot I will be 1, I dot j will be 0. Please remember all these. Like work done is force into displacement, or power is force dot velocities, like this. All right. Now Cartesian form properly we will study because these are very basics. Just quickly write down the properties, then I'll discuss the Cartesian form with you. See, when you have to multiply two vectors in Cartesian form. So this we were seeing individually. Now, if you have, let's say, proper Cartesian form system, you have the vectors 3i cap plus 4j cap plus 6k cap, something like this if you have. So if two vectors are given, the way we add to in Cartesian form unit vectors, we have studied how do we add two vectors. We just take the coefficient, the similar coefficients and add it, right? So coefficient of I cap from the first vector will get multiplied to the coefficient of I cap from the second vector. Like A1 will get multiplied to B1 and I cap dot I cap, this we have already studied, this is 1, so this won't be there. Similarly, A2 will get multiplied to B2. A3 will get multiplied to B3. So if you are finding out A vector dot B vector, so we will get A1 B1 plus, because I cap dot I cap, this will become 1. So no need to write I cap another time. A2 B2 plus A3 B3. For example, this question, let us discuss this, then I'll give you questions which you have to practice by yourselves. A vector is 3i cap minus 3j cap plus 4k cap. And what is the B vector? I cap minus j cap minus k cap. So yes, A vector dot B vector. Let's start with Martin.
Ma'am,
Yes.
3.
3. Very good. Because 3 multiplied to 1, here we will get 3 only. Yes, Sarah. Next.
-3.
Minus 3 into minus 1. This is minus 3 into minus 1. That will be plus 3, not minus 3. This is minus 1, no? So minus 3 into minus 1. Yes, Yasir. Yasir, last one. What will I write here, Yasir? This one, this one. Till here we have done, no? Minus 3 into minus 1. For the k cap, how should I write? 3 plus 3 I have written. 3 for this, 3 for this. What should I write for here? Minus 4. Yes, it would be minus 4. So what are we getting? 6 minus 4, that is 2. So we have resolved the vectors. Our final answer is 2. Some more questions I'll give you. This you will practice first by yourself, then we'll discuss. Quickly note it down from here. See, the force that is given here is 2i cap plus 3j cap minus 5k cap. Now, displacement is not directly given to us. We have the initial point and we have the coordinates of the final point. Like a 2 comma 3 comma 0. So you have to construct the unit vectors by yourself. See, this is x-axis, this is y-axis, this is z. So we can place ra, vector ra. This will be 2i cap plus 3j cap, and it's 0 given. So it means no need to write k cap. 0 k cap means 0 only. So RA, instead of giving in this Cartesian form, it is given in the form of coordinates 2 comma 0 comma 3. Nextly, we have this final point. So RA, this is from A to B. So A becomes your initial point and B becomes your final point. So RB, B becomes, this is again 4i cap plus 2j cap plus 1k cap means I can directly write it as k cap. Now, what is the displacement? Displacement is RAB. Remember, in relative velocity, I've told you. How do? We subtract the two vectors. So final minus initial you will get as 4i cap plus 2j cap plus k cap minus 2i cap plus 3j cap. This addition and subtraction of the Cartesian form unit vectors we have already studied. So what is the displacement coming? Change in actual displacement coming. 4i cap minus 2i cap is 2i cap plus 2j cap, and this is plus, no, this is 5j cap. See, 2i cap plus 2i, this is 4i cap minus 2i cap. So this becomes 2i cap. Then from here we are having 2j cap plus 3j cap. So we have to change the signs as well. Look here. We are subtracting these vectors. So this is 2i cap plus 3j cap. When you are subtracting them, we have to change the sign. So this becomes minus, this will also become minus, right? Because we are subtracting them. This is B, this is A. This is B, this is A, final and initial. So this will also become J cap. 2j cap. So this becomes minus 3j cap. So let me write it with the proper signs only here, over here. So this becomes 4i cap minus 2i cap. That is 2i cap. 2j cap minus 3j cap. This will be minus j cap. And what is left? Plus k cap is only left because it is 0 k cap over here. So you have R vector with you. And what is the value of force given? Force is already given in the question. That is 2i cap plus 3j cap plus 5k cap. No, I am minus 5k cap. This is minus 5k cap. This is minus 5k cap. So what do we have to find out? We have to find out work done, that is force into displacement, F dot S. What have we studied? The coefficients of I cap get multiplied. So that becomes 2 into 2 plus coefficients of J cap get multiplied, minus 1 into 3 plus coefficient of K cap gets multiplied, plus 1 into minus 5. So what is our final answer coming? 4 minus 3 minus 5. So 4 minus 8. So minus 4 joules. So minus 4 joules is the complete answer for this question. Note down the question, note down the solution. Some more questions we'll practice. I think question you all have written. Note down the solution. One more question we'll practice. Text me done once completed.